In this video, we're going to go through exploration number 1, which is learning target 3.2.4. So in this first part, there was a Desmos exploration. And so if you have not done that exploration, please make sure you go do that before you watch this video. So one of the things it talked about is the solution to equations. So in the Desmos, it asked you to place a point on the line and then asked you to decide what a solution to an equation was. So in general, a solution to any equation is going to be any point that makes the equation true. So that's kind of like the general definition. What does that mean though? It basically just means that when you plug in x, you get out y. So if I have a coordinate point 4, 2, if that's a solution to the equation, it means if I plug in 4, I get out 2. Then it talks about a system of equations. So that's the new unit that we're moving into, our systems of equations. So a system of equations is a set of 2 or more equations. So a system just means there's more than one. And then a solution to that system, kind of putting both of these things together, now it's not something that makes the first equation true. A solution is any coordinate point that makes both, I'm going to put in parentheses, or all, if there's more than 2, of the equations true. So now when I plug in x, and I get out y for all of the equations I'm dealing with. So if I have 2 equations, I plug in 4, I get out 2 both times. So today we're going to be talking about how to find that point, so a point that makes them both true, using graphing, which is something that we have done before. And so we kind of want to remind ourselves how to graph both of our methods. So to graph in slope-intercept form, we kind of have 2 steps. So step 1 is to plot B on the y-axis. So B is our y-intercept. We begin with B. Then step 2 is to use M as the slope, which is rise over run, and we call that moving with M. So that's if something is in slope-intercept form. We also talked about graphing in standard form or any other form besides slope-intercept. To do that, we want to find our y-intercept by plugging in 0 for x, and then finding our x-intercept by plugging in 0 for y. And those don't have to go in that order, but that's kind of the concept. We want to find both of our intercepts and then plot them. So that's kind of just a review from last unit. And so now we want to talk about how are we actually going to solve the system using this method of graphing. So I'm going to go through this example with you guys. So we have 2 equations here and we need to graph both of them. And so to be able to do that, I'm going to do this first one in green. I find it helpful to color code mine, so if you want to use like 2 colored pencils every time, you can do so, but I think it's a lot easier. So for this first one, this is in slope-intercept form, so I'm going to begin with B, which is my 5. So I'm going to go up to 5 on the y-axis and put a dot. And then I'm going to move with M, so now it tells me to go down 1 and over 2. So this is my rise and then my run. So I'm going to go down 1 over 2, down 1 over 2, and so on. Since I don't have a ruler for this video, I'm going to keep making dots so I can make this as accurate as I can, but you guys probably only need 1 or 2 or 3 dots, and then you should be able to draw your line. So my line should look something like this, and I should have arrows on the ends. So now my second line, I'm going to do this one in red. This one is in standard form, so we need to make sure that we find our x and our y-intercept. So to find our x-intercept, we want to plug in 0 for y. So we have 2x minus 3 times 0 equals 6. Well, negative 3 times 0 just cancels, and I'm left with 2x equals 6. Divide by 2, and I get x equals 3. So this I'm going to plot on my x-axis. So x equals 3, I'm going to plot that there. Then I'm going to do the same thing to find my y-intercept, but I'm going to plug in 0 for x this time. So I have 2 times 0 minus 3y equals 6. Again, 2 times 0 is going to give me 0. Cross that out. And we're left with negative 3y equals 6. Be really careful you don't forget that negative right there. It's very common, so make sure that if that's still there, you pull it down with it. Then we divide by negative 3, and we get y equals negative 2. So I'm going to go down to negative 2, and I'm going to plot a dot. And then since I don't have a ruler, I usually only have these 2 points. If you want to make yours more accurate, you can look at what is the slope between these 2 points. That slope has to be the same for everything. So to get from this dot to this dot, I go up 2 over 3. So I'm going to go up 2 over 3, plot a dot, up 2 over 3, and I can start to draw my line. Sorry about not having a ruler, but we kind of get the point. So then a solution is the point that makes both of these true. So on a graph, what that looks like is the point or the points that they have in common. So that point that they share is right here. We crossed right at this spot, and that's the only point these 2 lines are going to cross. So my solution is that point. So I'm going to go count that over. Remember, x's come first. So 1, 2, 3, 4, 5, 6. So my solution is 6, comma, I went up 2, so 6, comma 2. If I want to check this solution, I could plug in the x value right here, and I should get out 2 for my y value. So if I plug in 6 right here, and I do the math, I should get 2. The same thing should happen for this bottom equation, and that will prove that I am right. So now there's a couple of special solutions. So this is kind of the gist of what we are doing. We're going to graph 2 lines, see where they cross. That point is the solution. But then there are some special things that happen. Really quickly, this last little part, it says to find a solution to a system, you must find their point of intersection. And then it's just really important that you use a ruler and you double check. Because if you're even a little bit off, you'll get the wrong intersection point. So you got to make sure you're super careful. That's why I did so many dots when I did mine. So now there's a couple things that can happen. I am going to just graph these lines by myself, but you know how to graph all of these, so you should try those on your own right now. So pause the video, try those ones, and then hit play when you have them drawn. Okay, so this is approximately what you should have gotten. Remember, I don't have a ruler, so make sure that yours look a little bit better than mine. But these first ones are parallel lines, so these do not cross. You want to be extra sure that they're not just a little bit off. These should be parallel. So for parallel lines, remember we defined a solution as where the lines intersect. Well, these lines don't intersect. So if we had to describe the solution, we would have no solution. So if you graph parallel lines, you know they're not going to cross, so you want to say that they have no solution. Our next one are coinciding lines. So your lines should lie right on top of each other. They should be exactly the same. Well, if we're defining a solution as where it touches, where do these lines touch? Where does the blue and the green line touch? Well, they touch everywhere. So instead of having no solution, Coinciding lines are the same line, have infinitely many solutions. They're the same line, they share every point in common. And then lastly, this is the one that we looked at in the example and in the U-try, where lines just cross at a point. So if you can see where they cross down here, and that's just at one point. So for these ones, they have one solution, and you need to give the coordinate point. So you should have an answer of x comma y, the one point they have in common. Okay, so this should help you figure out how to find the solution of a system of equations from graphing. So a lot of review from last unit, and then just putting some things together. So instead of graphing one line, we're now graphing two.